All right, so this is our last section for the standalone 1324. The CoRec 1324, you have one more section on matrices, but it's a short and sweet. So 3.4 is present value. So the difference between present value and future value, your amount is increasing. So it's like an investment. With present value, your amount is decreasing. So in other words, a present value would be what you could use for, say, you're borrowing money. So when you borrow a certain amount, what's going to happen is you're going to be charged an amount of interest, but as you make payments, that amount will decrease, right? So when you make payments, if you have a 6-year loan, by the time you get to the end of 6 years, you will have paid off the amount plus the interest. So two big differences between future value and present value. The first one is with future value. I'm going to go ahead and write it. With future value, just so you can see it, you can see it's the same thing. The payment is off by itself in both of them. But with future value, you have the subtracting one after your exponent, after your parentheses, okay? Where present value, we are subtracting, you're going 1 minus what's in the parentheses, okay? So that's the first big difference. The second big difference is right here. With present value, your amount is decreasing, so your exponent is going to be negative. That indicates that you have a loan that you are paying off. Where with a future value, your exponent is positive, which means your investment is increasing, it's growing. So just like when we did with growth and decay, if we had something growing, we had a positive exponent. If we have something decaying, we have a negative exponent, so it's going down. So those are the two big differences. Make sure that you pay attention to it. The concept is basically the same. Your textbook and MyMathLab uses I. I change my I to R over N because sometimes you'll be given the rate and the number of compounds. I use, in the textbook it uses N. I use NT, which number of compounds times time. And then in the textbook, it uses M for number of compounds. So I hope that is not too confusing for you to go back and forth. Sometimes you're going to need the R over N. Sometimes they're going to give it to you as just an I, which is for interest, not I like imaginary number. Okay, so let's go ahead and start. The first one, we're looking for present value. So I'm going to put my information over here. That's what we're looking for. We have our I is 0.027. So in this case, they're just giving you I. You don't have to worry about the R over N. They're giving you the payment. The payment is 180. So remember, with future value and present value, you have a sequence of payments. It's not just a one-time payment. So when you're looking at the word problems, make sure you identify, is this a number of payments, like a continuous payment process, or is it a one-time payment? And that will help you decide, do you use future value, present value, or do you use just compound interest? And then N, from MyMathLab, is 21. So remember, N is N times T. So they give it to you as one number. All right, so now all we have to do is plug in our information. We're looking for PV. We know the payment is 180. 1 minus 1 plus I. They gave you I as 0.027. Raised to the negative 21, because they give you N, all over I, so 0.027. So make sure you identify, are they giving you the rate and the number of compounds, or are they giving you I as one number? So now it's just a matter of, let me grab my calculator. It's just a matter of calculating it. Order of operation is huge. You have to know order of operation. So order of operation means I'm going to do what's inside the parentheses first. So 1 plus 0.027 is 1.027. And now I'm going to raise that, so you can use your hat key. Raise that to a negative 21. Make sure you use the negative key on your calculator, not the minus key. Two different things. Okay? So from that, and I always write down my answers so that I have something to refer back to. So this right here raised to the negative 21 is 0.57150585555, all divided by 0.027. And then I still have my 180 over here, and we are looking for our present value. Okay, now this is another mistake that is easy to do. First one is forgetting the negative on the exponent. Second one is you are not doing 0.57 minus 1. The one in the present value case is positive. The 0.57 is the negative. So you're going to go back to here and do 1 minus 0.5715, and don't round yet. Oops. Hang on. Hit the wrong button. Okay. Equals. So now the top is 0.4284941445 divided by 0.027. So now I'm going to do my division. So divided by 0.027, and I get 15.870153 times my 180. So times 180. So my present value is 2856. Ooh, I ran out of room. 2856.63. Okay. So what that means is this is how much I can borrow. All right. If I know my payments are $180 times 21, I'm actually paying. So here's what I'm doing. I'm actually paying. I did 180 times 21 because that's how many payments I've made, and I'm multiplying, and I get 3,780. Well, why the discrepancy? Why is present value 2,856, but when I multiply my payment times how many payments, I get more? Well, that more is your interest. So if you want to find out how much interest you've paid, you're going to subtract the two. So in this case, you paid $923.37 in interest. Okay, so that's how you'll find interest. The PV is how much you can borrow. Okay, so that's what present value means. That's how much you can borrow. When you make all of your payments, you have actually paid $3,780 to borrow $2,856. Okay, so you paid the bank $923 in order to buy whatever it was that you bought. Okay, so I'm going to stop there and I'm going to reset and show you how to find payments.